Hello, welcome back to Cracking the Cryptic, and I'm delighted to have been sent a cricket-themed puzzle from the Netherlands. Now, you may think that's either abstruse or just an unusual mix, but the World T20 Cricket World Cup is on at the moment, and the Netherlands are in it, and they're not doing badly at all. Just before filming this, I have seen that they very nearly, well, they gave South Africa a good fright and had them reduced to 3 for 3, which, if you know your cricket, is a very poor start to the South African innings. South Africa did recover to win. I am not going to talk about the England-Australia game, but I am going to look at this puzzle in a minute. Now, don't forget that on Patreon we've got the wonderful Blobs' marvellous Lord of the Rings, fantastical in two senses of the word, Sudoku hunt, and people are loving it. There's lots of content on Patreon, including Simon's crossword solved from Thursday. Then we've got my tribute to Richard Rogan, and crossword is his very hard puzzle that he himself set, the Times Monthly Club Special. So that's going up. That's, yeah, actually Sunday morning, so all good. And there's all sorts of other content on Patreon. There's all of our apps which feature line Sudoku. Of course, there are some Dutch whisper puzzles in that, as today's is. And what else we got? We've got Sven's Sudoku Pad and our merch. Do check it all out. But I am going to launch into... Now, James tells me that the Dutch cricket team are called the Flying Dutchmen, which I didn't know. And I mean, obviously the Flying Dutchman's a famous steam engine. No, was it? No, hang on. I think it was originally a yacht or a ship. But Flying Dutchman is a familiar phrase. I'm surprised the cricketers have taken it, because cricketers don't really do a lot of flying, do they? I suppose they might fly through the air to take a catch. T20 is the 20 overs each form of the game, in which you will be, if you don't know cricket and you don't know the game, you won't know, and you wouldn't guess, that the T in T20 actually stands for 20, weirdly, because both innings are 20 overs long. That's 6 balls each in an over. So the first innings is 20 overs long, and so is the second innings. It's very strangely named, but that caught on in the early days of the form of the game, and there it is. That's what it is. And the competition will run on for a month and build up to a final in about 25 days from now, I think. Anyway, the Dutch are in it at the moment and doing fine, and we will commemorate that with this puzzle, and I shall do the rules now. James, I think, is a proud Dutchman and has come up with a Dutch Whispers puzzle. Normal Sudoku rules apply. That's 1 to 9 in every row, every column, and every 3 by 3 box. Adjacent digits along an orange line have a difference of at least 4. That's the rule with Dutch Whispers. And cells separated by a 6 ball sum to 6. 6 is, of course, the big hit in cricket, equivalent to a home run, I guess, in baseball, although, well, both are fairly frequent, especially in T20 cricket, where the emphasis is on going for big runs quickly. Anyway, we will have a go at the puzzle now. Do click the first link under the video and try it. I'm going to start now. Let's get cracking. So, there's a lot of orange lines in this puzzle and not a lot else apart from the 6s. Right, this 6 is on an orange line. Obviously, a 6 pair is either a 1-5 pair or a 2-4 pair. But this pair are neighbouring each other on the orange line, and so we know that they can't be the 2-4 pair. They must be the 1-5 pair. And in fact, this in the same box is now a 2-4 pair. And now this cell specifically can't be 2 or 4, but it's on a 6 ball, so it has to be a 1-5 pair. And we can just roll that over to the other two as well. This cell and this cell can't be 1 or 5, but they're on a 6 ball. So they're a 2-4 pair. Now, you may think that this looks like a deadly pattern, and it does look like a deadly pattern, but it will be resolved because one of the pieces of it is on an orange line. In fact, uniqueness will probably tell us that that digit is going to end up being a 2. But we don't use uniqueness because one of our goals on this channel is not just to solve the puzzle we're given, but to prove that it is uniquely solvable and only has one solution. And if we used uniqueness, we wouldn't be proving that. So we don't. If you're in a competition, feel free to use uniqueness. Feel free to use bifurcation. Get the best time you can, as long as you're sure about the solution. Actually, we can use the double X-wing nature of this, if not the deadly pattern nature of it, to say where are 2 and 4 in the top row, they're going to have to be there and there. They can't be here because of the 2-4 pair looking up at that, but I doubt that that'll help us solve the puzzle, but it is nonetheless true. Now, the rest of the digits in column 8 are 3, 6, 7, 8, 9, but the pair that are connected by the orange cell, well, they can't be 2 digits from 6, 7, 8, 9. They would be too close together. So one of these two is a 3. And therefore, the other one is not a 6, because the difference needs to be 4 or more. Also, we can take 3 out of these other cells, and this one now, on the 0, is a high digit. Okay, now I haven't really gone into the strange form of high-low alternation that we get in Dutch whisper puzzles, but it's time to look at that now. So the way that it works is generally digits along an orange line will alternate between higher than 5 and lower than 5 to maintain the 4 difference. The only exception is when 5 itself appears. And when that happens, 5 must have as its neighbours either 1 or 9. As we see down here, 5's neighbour is a 1. And 5's neighbour is always 1 or 9, and that means that 5 is the only digit with the power to change the alternation along a line. And it doesn't always do it. If this was 5, those could both be 1, and the alternation wouldn't have changed. 5 would just have masqueraded as a high digit for a moment. But, on the other hand, if you went 1, 5, 9, then you have changed the alternation that would otherwise go high, low, high, low. That's a long-winded way, but it actually matters because it's how I think of the puzzle. In fact, this digit, look, I hadn't realised, it sees all of 1, 2, 4 and 5 in its box. But it has to be 4 away from whatever this is. I think it has to be 3. I don't see what else it can be. It has to be effectively low because it can't be 5. So this is now not 6 either. And 6 is definitely in one of those cells in the column. Oh, and there's definitely a 3 in one of those two as well. Now, what else have we got going on here? 3 is going to be next to a high digit, 7, 8 or 9. This, well, it's probably going to be low, but it could be a 5. And then the trouble is, after that, well, we just don't know. This could be a 5 if that was a 9, but it could be low and that could be a 5. Then this could be high or low. And this all gets very uncertain around the left-hand side of this O. So, at least we got one digit in the grid. Now, bingo. This one cannot be a 3. And that is because 3 of the cells in the box touch it on orange lines. Now, it could just be a 3 then, if they could be 7, 8, 9. But look, they can't because of this cell. If you put 7, 8, 9 in these 3, you've got nothing left for this cell now. So that is not the 3. The 3 in the box is there. This is 7, 8, 9. This is also 7, 8 or 9 because 3 was always neighboured by 7, 8 or 9. And that places 3 in box 3. This must be low-ish. And it's not 2 or 4 or 3. So it's 1 or 5, I reckon. Now, the trouble is, well, no. I mean, I want to say this has to be high. But no, it doesn't, because that could be 5 and this could be 1. 5 is a beast of a digit on a Dutch whisper line, because it just throws your expectations out the window. Hits them for 6, one might say, in cricket parlance. Right, where are we next? We've got that 1, 5 pair and 2, 4. There's not a lot of room for low digits here. And yet these ought to be low if these alternate. One of these ought to be low if these alternated properly, if they weren't messed up by a 5. But they might be messed up by a 5. I mean, we are going to have to think in these terms, I suspect, to solve the puzzle. So no apologies for kind of continually thinking in high-low alternation and fives messing it up. That is just the way we have to go about this. So these are fairly high digits, 6, 7, 8 or 9, just from what's left in the box. We haven't quite got a triple in column 7 there. This can't be 6, 7, 8 or 9 though, because of that. So in fact this makes up the quadruple, 6, 7, 8, 9. They're all high, and therefore this is 1, 2, 4 or 5, lowish. Now this is next to 2 or 4. Okay, well this has to be high. 2 or 4 are useful because they don't permit 5 next to them. So these are definitely from 6, 7, 8, 9. That doesn't really help much else. This is now, well, low or 5 because of that. Oh, that's quite big. This is quite a big deal. Yeah, given that this one is 1, 3 or 5, must be. But look at that pair. They have to now be a 1, 5 pair. That can't be 3 because of this. So we've found a 1, 5 pair. They are changing the alternation of high because both of those are high. So one of these cells that I've got highlighted now is sitting next to 5 and is a 9. At least one, maybe both. But at least one of them is a 9, and they both see that cell, so that can't be a 9. They also, sorry, it's those two. They also both see those cells, so there's no 9 there. Anything else? Not really. It's interesting though. That goes to high. Yeah, there's no real constraint on how high these digits are. Let's have a look at this row. Right, where's the other digit out of 1 or 5? It's not here because there's a 1, 5 pair there. One of them is obviously here. The other one is on this pair together with a higher digit. And therefore this is higher, 6, 7, 8 or 9. I could have just done that from this box actually. Now this is not 6, 7, 8 or 9 in this column because of that. But I don't know what it is, so I'll just write in the candidates for now. And I've kind of got about as far as we can on this bat, which is annoying, but I think we have for now. It was interesting that one of these is sitting next to a 9, but oh, that stops this being a 9 as well, actually, because they do both see that cell. But it doesn't really, I mean, all I know is this one could be a 9 if that's a 9, and that would be a 5. Yeah, I can't disprove either of those. These two. Okay, these are interesting. Now, we discovered that one of these is either 1 or 5. Now, that could be changing the polarity alternation, which would have to occur if these two highlighted cells didn't include a 3. If 3 was there or there in row 3, these two would both be high, and these would have parity alternation. Now, let's think about this digit. This has to be fairly extreme, just as that one had to be. That had to be 1, 2, 3, 7, 8 or 9. I think that is the case for this as well, because it has 3 neighbours, and that does put a bit of pressure on a digit. Now, it's not allowed to be 2, 3 or 4 from the row, so I'm going to bother to ink in 1, 7, 8 or 9 as the possibilities. Now, if this was a 1, then these can be from 5, 6, 7, 8, 9. That's fairly unconstrained, but it would definitely make this a 5, which would make this a 9, which would give us something to work with. If this was a 7, I think we can probably falsify that. These would have to be 1, 2, 3, but 2 is in one of those cells. So it's not a 7. If it's an 8, these are now going to have to be 1, 3, 5. No, 8 won't work either. It can't be next to 5. It has to be next to 3 digits out of 1, 2, 3, 4, and that's impossible given those. So this is an extreme digit, 1 or 9 here. Ooh, I don't quite know what it means. Now, if it is 9, these ones are 1, 3, and 5. Now, is there a problem with that? I don't think so. I don't think we can count the alternation along those lines as of significance. If that was a 1, these are selected from 5, 6, 7, 8, 9, which has a degree of freedom, but on the other hand, that becomes a 5. Now, if this is a 9, that's not a 9, and therefore it's 6, 7, or 8, and that can't be 5. And therefore that is 5. Right, whether this is 1 or 9, I think this ends up being 5. Bear with me while I try and work that out again. If this is a 1, that's definitely a 5. If this is a 9, that is not 9, it's 6, 7, or 8, and this can't be 5, so that must be 5. So row 2, column 6 is always 5. And that's a 1 at the top, and this has now got to be a 9 on the line. And 9 in box 9 is in one of those two. 9 in column 8 is in one of those two. Well, that got interesting. Did it not do any more? The rest of these digits are from 3, 6, 7, and 8. Now, what does that do here? No, even more important, along here we've only got 2 cells for 1 and 9. There they go. Now, the 9 cannot be touching 6, 7, or 8. So the 9 is definitely touching a 3 in one of those cells. And 3 can't be in the non-orange cells in row 3. The 1 could be touching any of 6, 7, or 8. But these two include a 3 and 6, 7, or 8. Ooh, look at this. If this one is 6, 7, or 8, what's this? It has to be low, can't be 5, and yet it sees 1, 2, 3, and 4. It's impossible. So that's the 3. What a beautiful bit of the puzzle. That's a 9, that's a 1, this is high. Oops, high, 6, 7, or 8. Now 3 has to be next to 7, 8, or 9. Now this is low, and I don't have to include 5 because of that digit. Now I'm hoping to work towards alternation and joining up on this line. This is high, but I now do have to allow 5, which is a shame, because it means I don't know much about this. This could go low again. It could be, this could actually go high again. Oh, it's almost going to have to for the alternation. This can't be 5 because that isn't a 9. So this is low enough to be 1, 2, 3, or 4. Now this cell, yes, that means this is 5, 6, 7, 8, or 9 as well because of that. And suddenly we can join these together. They have to be a 5, 9 pair. Oh, that's beautiful. That's just like how it worked up here. 5, 9 pair here. So now by Sudoku that can't be 9. And this can't be 9 as well, actually. And one of them is a 5, and therefore one of these cells is a 1. Now, is that going to do any magic this time? It did a little bit last time. Not sure that it helped much in the end, but it did something. Oh, I've just noticed this can't be a 9. Both of those, for this to be a 4, they would both have to be 8 now. It does look doable. Wow, okay, this second bat was I think exactly as helpful as the first one, which is a bit strange. Now, this is 5, 6, 7, or 8 next to the 1. 3 is in one of those cells. Can I use the 1 looking down at the long strut of the T of T20? Probably not. Can I use this? One of these, okay, one of these has to be a 1 to be next to the 5. All that means to me is that these cells can't be 1s, which isn't as helpful as I want. Can that be a 4? Not worth talking about. I mean, it can. 9, 5, 1. I was hoping to limit 3 in this box, but it seems to be confined to those 3 cells, which is too many to be useful. 6, 7, 8 triple there. Can I come down the grid again? 6, 7, 8. Oh, 6, 7, 8 triple here. Oh, that's quite interesting. Unexpected as well. That can't be a 3 by Sudoku. So this row, this digit sees that 6, 7, 8 triple, the 3 and the 5, 9 pair. So this is 1, 2 or 4. And in the rest of the row, I have the other digit from 1, 2 or 4, plus 5 and 9 to accommodate. Well, 9 can't be here because of the 9 pair there. So 9 ends up in one of those two. And 9, I could have done that by an X-wing on those 9s. And this is either the 3rd digit from 1, 2, 4 or a 5. Well, I'm going to fill in those candidates. That can't be a 3. I seem to have a 1, 2, 4, 5 quad now. So this is from 6, 7, 8 or 9, but it's not 9 because of those. So 6, 7 or 8. I don't know if we're building up a picture of high digits in the puzzle. Maybe I should have been colouring. Maybe I should. It's intriguing how much has been done in terms of pencil marking with how few actual digits posted, and all of them on orange lines so far, apart from, I suppose, that one. Now, what about these two? Do they have any effect on each other? If that's a 6, this has to be 1 or 2. If that's a 4, this is an 8, we said. Then this would have to be 7. And that would have to be 6. That feels quite powerful. Maybe not enough. One, 2, 4. This can't be 1, 2, 4 or 5 or 9, but annoyingly it can still be 3. Oh, I'm going to have to somehow take these T and 2 and try and get something going on them, but I don't know how to yet. I don't know where to start with those. Maybe I should look at this left-hand side of the O again. Ah, it doesn't have a 5 on it. Now, if one was to treat those both as low, in fact, if neither of those was a 5, this is quite an interesting point. If neither of those was a 5, they would both be low, and these would both be high, and that's impossible given that neither can be a 5. So therefore, one of these two is a 5, and one of these is therefore an extreme digit, a 1 or a 9. But if one of those two is a 5, this digit can't be a 5, which I could have worked out from that being 6, 7 or 8. I hadn't spotted that. Bother. So one of these is a 5, and one of these is 1 or 9. Now, does that lead to anything? If one of them was a 1, the other digit would be from 6, 7 or 8. And that would form a triple with these two. That would have to be 9 in that case. In fact, even already, we've got 1, 3, 2, 4, 5 in this box. These are from 6, 7, 8, 9, and one of them is a 9. But does one of these have to be high, or could this be... Yes, one of them has to be high. They can't be a 1, 5 pair. That's going to be the 4th one out of 6, 7, 8, 9. Therefore, everything else in the row, in the column rather, is from 1, 2, 3 or 4. This one can't be a 1 because it sees a 1, 5 pair. This one is not necessarily interesting because that could be a 3. You know, if that wasn't a 3, this has to be low. This has to be 1, 2, or 4. And that would then tell us some things about this line. But it absolutely doesn't have to be low if that's a 3. Then we've only got 2 high digits there, 1 there, and we need another one here. So we don't learn which way around that goes. We know there is an extreme digit here, but we don't know whether it's 9 or 1 yet. And it's next to a 5 in one of these. We can't, I was going to say we can't have both 1 and 9. I don't even know that actually, so we could. This is tricky to keep going in, isn't it? Okay, 2 and 4 can't be in those cells. These digits are going to be, well, they are going to be too high and too low. Although 5 might appear next to a 9. But it couldn't appear there or there because you can't have another 1 in the column. So these are definitely 1 high and 1 low, just as these two are. Oh, what about this trio? What have we had in terms of high and low here? Don't really know, because we might have had a 5 somewhere. That's really weird. 5 messes things up so much. What did we learn earlier? That one of these was a 1. So none of these are a 1, and therefore one of these two is a 1. And that doesn't really advance us. Oh, goodness. If that's not a 5, then one of these two is a 5 and that's a 9. So if that's not a 5, that's a 5. Oh, previously with that 1-5 pair, we worked out something based on that, and that sorted out this pair. Does that work from here to looking at that cell somehow? I don't think it does. It's not the same thing at all. Why did it work here? Oh, it was to do with this round the corner piece. Well, we have that going on. Okay, let me just try and recap how we got this going. It was to do with that. In some way, whatever this was, this had to be extreme 1 or 9. Okay, we're not in the same position here. However, for this to be a 7, that has to be 3, 1 and 2. That would then have to be 4 or 5. What does that imply? This would be 8 or 9, just as that would. So if that's a 7, this is 8 or 9. And this is low. I can't see how to make that work. This cell, it sees 1, 2, 4 and 3 again. So this is either 5 or high. Now, that means one of these is low. Can both of them be low, which is the likely outcome of this being, if this was anything other than 5, they both have to be low. But yes, that is possible in this column. But if that's a 5, this is a 9, and that's a 5, and that's a 1. Now, let's go back to the thought that one of these at least has to be low. It's quite interesting. If this is low, then at least 4 low digits have gone here. From 1, 2, 3, 4, 5, if this is low, which it probably is, given that that's a 5. In fact, no, sorry. If this is a 5, this can never be high, can it? because the only high digit it could be given that is a 9, and we've got a 5-9 pair, so this is low, right. And now we've got 4 out of a 1, 2, 3, 4, 5 set. We can't make those too low. We can't have a 1, 5, 9 parity changing, polarity changing thing here because of that. And therefore, this middle digit has to be the low one, because we can't have 2 of those being low because of the count of low digits in this row. So that is 2, 3, or 4. We now have a 1, 2, 3, 4, 5 quintuple. That means one of these 2 is a 5. That isn't. Much more importantly, this isn't, and it's a 9. And that's a 5, and that's a 1 that it's touching. We can't do the other cells, but that takes 1 out of a couple of cells, which are now a 2, 4 pair, and this pair is a 5, 9 pair in the row. We've got a 6, 7, 8 triple in that row and a 2, 4 pair. Now the 9 here takes 9 off this cell, which I have a feeling is important, not just because it definitely makes this a 9, which doesn't resolve any of those, but 7 or 8 here means that's not a 5. And therefore we've placed 5 in this box on the handle of the bat. And we can do a 1 and a 5 there, and a 1 and a 5 down here. One of these is a 1. Oh, that 5, well, that makes this the extreme digit, but I still don't know whether it's the 1 or the 9. Yes, I do, because we can't have a 5 here and that's low. So this has to be high. 6, 7, 8 or 9, and this is a 1. Bingo. And that puts a 1 here by Sudoku. We've got 4 1s looking into this box. Now, that was 2, 3 or 4. This is clearly a high digit, 6, 7, 8 or 9. This one is not a 5 because that can't be a 1. So it is 2, 3 or 4, low again, and this one has to be high again. And we do have proper alternation going on there. I want to say, where can 5 be in this column? But it does seem there's still 2 places. Now, what do we know about this? These are also high, and they are 6, 7 or 8, and that's a triple with that. So one of them is a 6, and that's really important because it makes this one a fixed 2. And this can't be 2 now. And 2 there takes 2 out of all of these cells. That could still just be a 4, yeah. 2's in one of those 2. 3 and 4 in this box are in these cells. 4 in one of those 2 and 3 somewhere in that middle row. And that means none of these can have a 3 or a 4. So we've got a 1, 2 pair now. And these are using 3 or 4 and something from 6, 7, 8 that isn't 6. Now that 2, 4 pair keeps 4 out of that cell. Now what about the alternation on this 2 figure? Because we've got all of the other alternations done now. Is there anywhere 5 can go on it? Just there. So let's ignore, well, let's not ignore that. This has to be high, but it could be 5. 5, 6, 7 or 8. Well, that is a quintuple. So this is 2 or 4. That's in a column with another 2 or 4 candidate. Pencil marking is clearly the way to go on this puzzle. That also can't be a 3, it's a 1. So that's a 2, that's a 1. This is a 4, that's big on this line. It has to be next to 8 or 9. That makes this a 2, that puts 4 in the corner, that's a 2. This pair are unresolved unless, yes they are, that's a 4. That's a 2, and the 6 ball over here gets resolved. 4 and a 2 there. 8 here goes in that cell. These are a 6, 7 pair. This can't be, neither of these can be 8. They're also a 6, 7 pair. These can't have 8 in either. I'm going to take the pencil mark out. Now, 5, 6, 7, 8, 9. We'll just think about, no, let's think about this next. Oh, this can't be 1, 2, 3, 4 or 5. 6, 7, 8 or 9. How can that be next to that? Well, We do get a 5 on this. I thought I'd ruled out 5 on this 2 thing, but I think I ruled it out from those cells, which is a relief, because otherwise the whole thing wouldn't work. 9 there, 5 here. This is low. We can't have another 5 on the line, so these two are definitely low. This one sees 1, 2, 4 in the column, so that's a 3. This one sees 1, 3 in the row, so that's 2 or 4. This digit is next to a 3 there, so it's 7 or 8. This sees 3 and 2, so that's a 4, that's a 3. These can't have 8 on, so they are a 6, 7 pair. Now we take 7 out of those cells. 3, 4, 8 triple, that can't be 8. Looking at this column, this is, oh, that's become an 8 in the box. That's going to finish box 8 entirely. That finishes box 5. That might just finish box 2, although I think I'm getting a little bit premature on that. No, maybe not. 6 and 8 here. Oh, sorry. I'm losing control of my modes. That's a 6, 8. That's a 7, 6. Now, this has to be a 2 on this orange line, as we expected from the beginning. Those can't have a 7 on. This is now 5 or 7 in a 3, 5, 7 triple. The central 3 columns are all complete. Might be able to complete these last 3 columns as well. 9, 7, yes, they're all done. Last 6 columns all complete. 1, 2, 5, 8, 6, 4, 3. These are a 7 and a 9. I know the order. That's a 2, and this is a 6, 8 pair down here. In this row, we have a 3, 4, 5 triple. Now that's a 6 by Sudoku, that's an 8 by the same method, that's a 5, that's a 9. I think we get to finish off now. Marvellous, this has been good fun. That is not 8, that is also not 8, so the 8 here is known. This is a 3, that's 4, 5, 4 there, and a 3 here completes a marvellous puzzle for the Flying Dutchman by James Copp. That's good fun. Great stuff, James. Solved in 33-34, which is a very... yes, I told you the Dutch had reduced South Africa to 3 for 3. That's a very appropriate time suddenly. Excellent stuff. So that's 3 runs for 3 wickets, anyone who doesn't know. Good fun there. Thank you, James, for that. And marvellous to get to do a cricket celebrating Sudoku for me. We'll see you again tomorrow, and bye for now.